Hi students, today we will learn about triangle inequalities, specifically the relationship between the side lengths of triangles and the angles that they are across from. There is a relationship there that'll tell us more about the triangle. So the first thing we're going to learn is the triangle inequality theorem. And it says in order for a triangle to be constructed out of certain side lengths, the sum of the shorter sides must be greater than the longest side. Okay, so if I take the two shortest sides and I add them together, that number needs to be bigger than the length of the longest side. If it's not, we cannot form a triangle. So in class, I will show you why that doesn't work. So here's a table that we're gonna try to fill out and determine based off of these side lengths. We're going to determine if they can build a triangle or not. All right, so the first one's done for you. Remember, you're going to figure out which two sides are the shortest. You're going to add them together. That goes in this column. And then you're going to write down the longest side, the side you didn't add with the others, and then you're going to compare them. So let's go ahead. If you want to pause the video and fill these in yourself, go ahead, pause now, fill it in, and then press play and we'll see how you did. If you want to do one with me, we can do one together first. So let's look at this second example. The two shortest sides are the 2 and the 2. So I'm going to add those together. I get 4. The longest side that I didn't use is 3. Because 4 is greater than 3, yes, it makes a triangle. So that's what you're going to be doing on each one. So this is what you should have. I want you to pay attention. All the ones that have a greater than should have a yes. So there were, looks like 6 of these combinations that worked. And then any of the ones where the sum was equal to the third side or less than the third side did not make a triangle. And the reason is because some of the sides won't ever, the two shorter sides will never reach each other to close the triangle. It'll stay like an open shape. So I'll show you what that looks like in class. So here are a few more examples. If you feel like you've got the concept down, you can go ahead and pause it and try to do this and then unpause. And we'll go over it together. So you can pause it right now. But what you're doing here is it says determine if the following sides will make a triangle, and if yes, then classify it by side. So we learned that in the last lesson, okay? So first of all, you want to make sure that you're adding together the two smallest sides, and they're not always going to be the first two numbers. A lot of times they are, but make sure you're adding the two smallest sides. So for number 1, we get 8 and 9 are your shortest sides. If you add those, you get 17, and that is greater than the longest side 10. So yes, it makes a triangle. Because all 3 side lengths are different, this is going to be a scalene triangle that it makes. All right, number 2. Our two shortest sides are the two 1s. So 1 plus 1 is 2, but compared to the third side of 2, it's equal. So it will not make a triangle, which means we cannot classify something that doesn't exist. Number 3, the two shortest sides are 6 and 6. We add those, we get 12. The third side that's longest is 10. 12 is greater than 10. Let me redo that guy. Greater than 10. So yes, it makes a triangle. Because 2 of the sides are the same length, they're both 6, this will form an isosceles triangle, which is the kind where 2 sides are the same length. Number 4, the two smallest sides are 3 and 5. When I add those, we get 8. The third side that's the longest is 7. 8 is greater than 7, so yes, this will make a triangle. Because all 3 sides are different lengths, this one is also going to be scalene. And then the last one, we have all sides are the same length, so any 2 that I add, I can pick 4 and 4. I add those to get 8. 8 is bigger than the third side, which is 4. So yes, this also makes a triangle, and since all 3 sides have the same length, we say that this is equilateral. That's the best answer. But technically, we know that isosceles means that at least two sides have the same length. So we could also say that this is also isosceles. All right. So the next thing we're going to learn is this. In a triangle, the largest side is opposite the largest angle, and the smallest side is opposite the smallest angle, which means that the middle length side is going to be opposite the angle with the middle size measure. So let's look at this example and see if we can't figure this out. So it says the measure of angle A is 120. I'm going to add that to my picture. The measure of angle B is 40. And the measure of angle C is 20. All right. So let's take a look at this. It says, what is the largest side? Well, the largest side is opposite the largest angle, just like it says up here. The largest angle is the 120. If I was to draw an arrow from that angle pointing to the opposite side of the triangle, it's going to point to this side BC. That means BC, segment BC, is the largest side because it's across from the largest angle. The smallest side, remember, is going to be across from the smallest angle, and the smallest angle is the 20 degrees. If I draw an arrow from the 20 degrees across my triangle, it's going to point at that side that's across from it, which is also going to be the shortest side, which is segment BA or AB. You can call it either way. Okay, so just to clear up, segment BA is across from angle C, right? That's that smallest angle. And then segment BC, that was across from angle A, that largest angle. Okay, notice, and this might help you with some of these other problems, the side that's across from an angle includes two vertices that are not that angle's vertices, if that makes any sense. So if angle C is the angle I'm looking at and I want to figure out which side's across from it, the other two vertices in my triangle, put those together, boom, there's your segment that's across from that angle. All right, let's try this example. Classify the triangle by sides. Then we'll list the angles from small to large. So if I'm looking at the sides, I've got 9, 12, and 15. Because they're all different lengths, we're going to say that this triangle is scalene. All right. Now we're going to list the angles from small to large. Let me erase this real quick. Okay, so I'm going to use some different colors here. First of all, the smallest angles across from the smallest side. So the smallest side was this 9. The angle across from it is angle B. So that's going to be the smallest angle. The next smallest side is this side length of 12. If I draw an arrow from it to the angle across from it, it's going to be across from angle C, which means angle C is that middle-sized angle. And then by default, of course, we can see the longest side is 15. The angle across from that is angle A. So angle A is going to be the largest angle. All right, so this is a great application problem. List the sides of triangle A, B, and C in order from longest to shortest if the angles of triangle ABC have the indicated measures. Measure of angle A is 10x, measure of angle B is 5x minus 17, measure of angle C is 7x minus 1. Definitely the very first thing we need to do is to just draw our triangle. So we'll draw any old triangle. We'll label the vertices A, B, and C. And then we'll put those angle measures, excuse me, where they go. So the measure of angle A is 10x. The measure of angle B is 5x minus 17. And the measure of angle C is 7x minus 1. Okay, so first of all, in order to be able to list the sides from longest to shortest, we need to know either the side lengths, which we know nothing about, or the angle sizes, which we kind of know some stuff about. We have expressions, but we still don't know how big they are compared to one another. So the first thing we're going to need to do is figure that out. So we're going to use something we learned in our last lesson, which is that the sum of the angles in a triangle add up to 180. So we're going to add the 10x with the 5x minus 17 with the 7x minus 1, all three angles, equals 180. We're just adding those together. So let's go ahead and solve this. The first thing we want to do is combine some like terms. 10x plus 5x plus 7x, those will add up to 22x. Then we can add the negative 17 with the negative 1. That gives us negative 18, and that equals 180. To solve, we'll move that constant to the right side to be with the other constant by adding 18 to both sides. So 22x equals 180 plus 18, which is 198. And then we'll divide both sides by 22 to isolate our variable. 198 divided by 22 gives us an x value of 9. Okay, so now that I know that x is 9, I can go back in and I can figure out how big each angle is. Okay, so I'm going to go to each angle measure and I'm going to replace x with 9. Just there, there, and there. Okay. So let's start with the 10x. That's easiest. 10 times 9 is 90 degrees. Awesome. And of course our triangle is not drawn to scale because it definitely doesn't look like a 90-degree angle. But we didn't know, first of all. Second of all, it doesn't have to be. We're just going to look at the information on the picture. All right, if I plug in 9 to the 5x minus 17 where x is, 5 times 9 is 45, minus 17 is going to be 28 degrees. And then for angle C, if I put 9 where x is, 7 times 9 is 63, minus 1 is 62 degrees. All right, so there are our three angle measures. Now we can list our sides from longest to shortest. So the longest side is going to be across from the largest angle, which is the 90 degrees. If I draw an arrow from that to the side across from it, that means BC, the side across from the 90, is going to be my longest side. My next largest angle is the 62 degrees. If I draw an arrow from that to the side across from it, that means that side AB is going to be my middle length size side. And then my smallest angle is the 28 degrees. If I draw an arrow from that to the opposite side, we see that side AC is going to be that shortest side. So these are the three sides listed from longest to shortest. All right, there's two more things we're going to learn. These are two theorems, which are just basically rules or laws that we follow that describe geometric figures and their relationships. And they're kind of opposites of each other. So if you understand one, the reverse of that is also true. So the first thing we have is the hinge theorem. Okay, and the hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, so if you see at the picture AB is congruent to DE and AC is congruent to DF, okay? I'm going to erase that for now. Then the longer third side is going to be across from the larger included angle. Included just means the angle between those sides. So let me explain what this means. So what we've got, let me do it like this. Okay, so since AB is congruent to DE, AC is congruent to DF. Okay, so you have to have two pairs of congruent sides on each triangle. Then, because BC, let me get my colors here, because BC is longer than EF, then that means the angle across from BC or opposite it, which is angle A is going to be bigger than angle D, which is across from EF. Okay, let me say that again. Let me get another color. So if two sides of one triangle are equal to two sides on another triangle, the opposite is also true. So the smaller third side, since EF is smaller than BC, then the angle across from EF, angle D, is going to be smaller than angle A, which is across from BC. Okay, so we could say BC is greater than EF, and we could say the measure of angle A is greater than the measure of angle D. All right. So the reverse of this is also true. It says if two sides of one triangle are congruent to two sides of another triangle, then the larger included angle is across from the larger third side. So it's basically kind of saying the same thing. So I've got congruent side, congruent side, congruent side, congruent side. So we're starting off with the same thing, but now we're starting with the angle and making a conjecture about the side length. So for example, since angle M is smaller than angle J, then that means the side across from angle M, side LK, is going to be smaller than the side across from angle J, which is HG, okay? Which basically means that HG or GH, whatever you want to call it, is going to be bigger than KL. So if we look at it the other way, since angle J is larger than angle M, then the side across from angle J, HG, or GH, is going to be bigger than the side across from angle M, which is KL. Okay? All right. So let's see what this looks like in an example. Okay, so let's apply this to an example. We've got two triangles. It says write an inequality. That means using, a greater than or less than, comparing AC's length to XZ's length. Okay? AC and XZ. So let's look at what we have from the triangles. They both have a length of 7, okay, and they both have a length of 9. Fantastic. So we've got the setup. Now we're going to look at the other side that they don't have that are equal, that are not equal, the other sides that aren't equal, and the angles across from them. Okay, so the angles that we've got 111 degrees and we have 119 degrees, okay? Now I know that 111 degrees is less than 119 degrees, right? So that means that the side across from 111 degrees, which is AC, is also going to be less than the side across from 119 degrees, which is XZ. Okay? So the relationship between AC and XZ is that AC is less than XZ. You could also write it as XZ is greater than AC. You could flip it around the other way. Those both mean the same thing. Okay? Okay, last example. Find the range of values. Anytime it asks for a range of values, you want to set up a compound inequality. So we'll look at what that looks like in a second. Let's look at what we have with these two triangles. Now these two triangles actually share this side, which means that it's congruent on both triangles, right? We also have this other side on each triangle that are congruent. Okay, so we need to look at the relationship between the remaining sides and the angles that are across from them. So I see that 7 I see is less than the 8. Okay, so 7 is less than 8. Now let's look at the angles across from the 7 and the 8, which means that 25, or sorry, the 2x plus 8, which is across from the 7, is going to be less than the 25, which is across from the 8, right? So these are the angles across from these sides, right? Now, a compound inequality requires two inequality symbols. So the other inequality symbol that we want, look at where your variable is. Your variable is on the left side. We want to have another less than and then a 0. And the reason why we want that is because this angle 2x plus 8 has to be bigger than 0. So we kind of add that to there. So we know we already know it's going to be less than 25, but we have to also mention that it's greater than 0 because we can't go into the negative numbers. Okay? So when you have this type of inequality, and you may or may not have done this last year, you can solve a compound inequality at the same time. So what I do is I put a line under both of my inequality symbols, and instead of having two sides like you do when you're solving an equation, you actually have three parts. So whatever you do to one part, you're going to do to all three parts. And the goal is to get the x by itself in this middle section. Okay? So the first thing I would do, if I wanted to isolate the x, is I'm going to get rid of that 8. And I'm going to get rid of that 8 by subtracting it. But I also have to subtract it from the other two sides as well to keep our compound inequality balanced. This goes away. I'm left with 2x in the middle. I'm going to bring down my less than symbols. On the left, 0 minus 8 is negative 8. On the right, 25 minus 8 is 17. Okay. The next thing to do to get x by itself in the middle is get rid of the 2, and we're going to do that by dividing. We'll divide all three parts by 2. Now we've got x in the middle. Bring down your less thans. Let me erase this line a little bit. And then on the left, negative 8 divided by 2 is negative 4. On the right, 17 divided by 2 is 8.5. And this is the compound inequality. So what this means, when x has a value that's less than 8.5, but that's bigger than negative 4, so it's between negative 4 and 8.5, when x is between those two numbers, that will make this 25-degree angle larger than that 2x plus 8-degree angle. And it'll also make the 2x plus 8-degree angle bigger than a 0-degree angle, which isn't an angle. Okay, so this one was a little bit more complicated, but if you have any questions, we can talk about them in class. See you in class.